Have you ever clicked a link and just wondered how it all actually works? Well, today we're pulling back the curtain on the internet's invisible rulebook. We're going to look at the hidden instructions that let your phone in, say, Tokyo, talk to a server in Toronto. Let's dive right in. I mean, really stop and think about it for a second. You've got your iPhone, your buddy's got an Android, you're on a Windows laptop, and you're connecting to some massive server running Linux. How on earth do they all connect and just understand each other perfectly? It seems kind of impossible, doesn't it?
Well, the answer is, believe it or not, surprisingly simple, but also incredibly brilliant. They all just agree to follow the exact same set of rules. A universal rulebook for how to package, address, and send information anywhere in the world.
And that rulebook, it's called TCP/IP. That stands for Transmission Control Protocol/Internet Protocol. And it's not just some kind of language, it's the absolute foundation of the modern internet. Seriously, without this thing, none of this works. And here's the wild part. This is not some newfangled tech. TCP/IP has been around since 1973. It got tweaked and refined over the years, and then in 1983, it became the official standard for something called ARPANET, which was the military network that, you guessed it, eventually grew into the internet we use every single day. So to really get how this rulebook works, we gotta look at its structure. Now, you might have heard of this super complicated 7-layer thing called the OSI model, but we can kind of ignore that because the model TCP/IP actually uses is way simpler. It's the Department of Defense model, and it's basically just a slimmed-down 4-layer version. And to make this crystal clear, we're going to use an analogy. This is the best way to think about it. Just imagine TCP/IP as a hyper-efficient 4-story digital postal service. Every single piece of data you send goes on a journey through these 4 floors. You can see the difference right here. On the right, there's that complicated 7-layer model I mentioned, but we're focusing on the simpler 4-layer DoD model on the left, because that's what the internet really runs on. These 4 layers, application, host-to-host, internet, and network access, those are the 4 floors of our digital post office. Let's break down what happens on each one. So let's take a quick tour. Up at the top, on the application layer, that's where you're writing your letter, your email, your web search, whatever. Down 1 floor is the host-to-host layer, and that's where you decide how you're going to send it. The internet layer is the main mailroom, slapping the full street address on the envelope. And finally, the network access layer at the bottom. That's the physical stuff, the mail trucks, the planes, and the roads that actually move the mail. And what's absolutely crucial to get is that each floor isn't just one big room. No, it's got all these specialized departments, which are the different protocols, each with its own specific job. If you look closely, you'll probably even recognize some of them, like HTTP for web browsing up on the top floor, or the 2 we're about to talk about, TCP and UDP, on the host-to-host floor. Okay, let's zoom in on that host-to-host layer, because this is where a really important choice gets made for every bit of data you send online. And the choice is simple. Do you send it as certified mail or as a simple postcard? And that, right there, is the huge difference between TCP and UDP. TCP is your certified mail. It establishes a connection, makes sure every single piece of the message arrives and that it's all in the right order. It's super reliable, but it has a little more overhead. Then there's UDP. UDP is the postcard. You just scribble the address, send it off, and hope for the best. It is way, way faster and super lightweight, but yeah, there's no guarantee it'll get there. So why would you ever use the postcard? Well, think about it. For an email or loading a web page, you need every single piece of data to show up perfectly. You can't have missing words. So of course, they use reliable TCP. But for something like your computer just getting an IP address, speed is everything. It's way faster to just shout out a request using UDP, the postcard, and get a quick response without all the formal handshaking. Okay, so we know the layers and we know the delivery options, but how does the data actually get packaged up for its big trip? It's not sent as one giant file. Instead, it gets wrapped in all these protective layers as it travels down through the floors of our digital post office. The process is called encapsulation. Probably the best way to see this in action is to just follow a single email and see what happens. So let's start at the very top, in the application layer, right at the moment you hit send. First thing, your email data is handed down to the host-to-host layer. It gets wrapped in what's called a TCP header, and now it's known as a segment. That header includes a port number, which is just like an apartment number on an envelope. It makes sure the data gets to the right application, your email program, and not, say, your web browser. Okay, next, that segment is passed down to the internet layer. Here, it gets placed inside an envelope by adding an IP header. This is where the main address goes, the unique IP address of your computer and the computer you're sending the email to. And just like that, our segment has now become a packet. And finally, the packet is handed to the bottom floor, the network access layer, and it's put into a frame. You can think of this as loading the envelope onto a specific mail truck. This frame adds the physical MAC address, which is a unique ID that's literally burned into your device's hardware. It's what's needed for that final local delivery step. So this whole encapsulation process, that's one of the biggest hidden rules that makes everything work. But there are a few other really clever little protocols chugging away behind the scenes. And that brings up a really good question. So the IP address gets the packet to the right neighborhood, the right local network, but how does the mail carrier know which specific physical mailbox, the hardware address, to actually put it in?
Ah, that's where this brilliant little protocol called ARP comes in. ARP, or Address Resolution Protocol, lets a device basically shout out to the whole local network, "Hey, I've got a packet for IP address 192.168.1.5. Who is that?" And the right computer just replies, "Yo, that's me. Here's my physical hardware address." It is such a simple, elegant solution for that final mile delivery. The main thing to take away from all this is that every single click, every email you send, every video you stream, it kicks off this incredible 4-layer journey. Encapsulation, addressing, delivery, it's all governed by these invisible rules like TCP, IP, and ARP. And it happens billions of times a second, all over the planet, completely hidden from view. You know, it is truly mind-blowing that a system designed almost 50 years ago still powers our entire digital world. And it leaves you with a final thought, doesn't it? As we dive headfirst into an age of AI and the Internet of Things, what will the next universal rulebook for communication even look like? What hidden rules will be governing the Internet of the future?